Okay, some part of it I will repeat it again. Okay, up to the last lecture we have covered up to the monolithic kernel and the microkernel. Okay, in today's lecture we are going through the system component activities. Okay, that the first component activities is nothing but the process management. Okay, in the process management, the first keyword as a process. So what actually means by the process? Okay, up to the operating system syllabus, we have discussed about the process and the program. So what is the actual definition for the process? The process is nothing but the task executed by the CPU is referred as the process. So any kind of a thing that is executed by the CPU is nothing but your process. Then there are the some kind of activities are running in your operating system by the printer spooler, name server, file server. So these all the activities are considered as the process in the operating system. Okay, then we will move to the next point. While executing such kind of a different programs or the process, we require some kind of a resources, just like your input output device, data, program, and the memory. So these are the resources required to execute the process, and these all the processes or these all the resources are the part of the processes. So we know that these all the resources are required to execute the process. So when process requires, we'll move to the next point. Process requires input that includes the complete execution component like a code, data, program counter, or register. So uh, these are the thing, just like a code, data, program counter, and the registers. These are the these all the requires to execution of the process. So these are the resources required to execution of the process. Okay, so there is a difference between a process and the program. Okay, when it can be asked into oral also. So what is the exact difference between the process and the programs? So program is nothing but the it is just a set of instruction that is stored in your secondary storage or the hard disk or in the main memory, but it is not in the execution. But the process is the thing, or the we can simply say the program in the execution is nothing but the process. So there is a always difference between the process and the program. You have to remember this thing. So what is the exact difference between the process and the program? And the process is only instant or moment of a program in execution. The program which is in the execution, we can simply say it as a process. So the process is the unit which measures the work done by the system. So we can say there are the number of processes in the running in the system, and one of that when it is going to be executed, we can say that the process number 1 to up to 500 processes are executed by the that system. So it is nothing but it is a measure to measures that we can measure by what the thing is done by the system. So the process we can simply set it as a unit. Okay, in this slide we know about the definition of the processes and the different points and the resources are required to execute the process, and these are all the resources is the part of the that process. Okay, then what is actually mean by the process management? The process management is the activity which is handled by operating system. Okay, it is just a activity which is handled by the operating system. Okay, so in which most of the activities are handled by the OS, such that is called as a process management. Okay, in the process management, these are the main 5 activities are handled by the operating system. So we'll go one by one and understood what it exactly means. The first activity is nothing but the creation and deletion of the system and the user process. So we know that how to create the process in the operating system, that is by using the fork system call. Okay, suppose I want to create one of the new process, so that is not, by using the fork system call we can see how to create the process. Okay, and when I want to kill any kind of a process, by using the kill system call I can delete that process or the kill that process. So the creation and the deletion of a process call is nothing but the creation and deletion of the process is the first task for the process management. Then second one as the suspension and resumption of the process. So when I want to suspend any kind of a process or the resume any kind of a process, so that is the another thing considered into the process management. Then next one as a process synchronization and the process communication. We know that there are the number of processes are running into your system. Suppose there are the 500 of process running at a one time. So we need to make the synchronization between the process. So no one process can interrupt the other one. So that is nothing but the synchronization between the process. And if there is a some kind of a data exchange, means process number 1 is dependent on the process number 2, so we need to pass some kind of a parameters there between the processes. So that is nothing but the process communication. So the process communication thing is also handled by the process management. So that is nothing but the task number 4 is that the process communication. The next one as the deadlock handling. So what it exactly means, the deadlock. So deadlock is the, we can say, the multiple processes runs at a time and does wait for each other. That is nothing but the deadlock situation. So simply we can say that when there is a, okay, I will use the pen here. This is the process number. Okay, we have the process number 1 and the, okay, I will use the pen, just a minute. Okay, suppose I am having the process number 1, process number 1 and process number 2. Okay, now these two processes are running in my CPU and these are the my all the resources. Okay, here all the resources are stored. Okay, in that, okay, I will just use the different sign here. Okay, in this input output is input input output is here. Okay, this is the your resource. Then hard disk is here. Okay, I will make it as a HDD, your hard disk. Okay, so these are the there are the number of resources are present into your system. So for the consideration we will take these two only, input output system and HDD. We have the two processes in your CPU running. So what exactly means the deadlock? We are discussing here what exactly means the deadlock. Okay, the process number 1 is simply reading. Okay, the process number 1 is simply reading the data from your input output. Okay, what is the process number 1? The process number 1 is reading the data from the input output, and where the process number 2 is also accessing the hardware uh, as your hard disk. Okay, it is accessing the hard disk, but at some point of a time it wants to access the input output. Okay, here also it wants to access the input output, but input output is now using for the uh, process 1 is using the input output, but the now process 2 also wants the input output. Okay, so in this condition it may happen that the process 2 is already accessing the hard disk and now process 2 wants the input output, but the process 1 is using the input output in this time. Okay, so in that condition it may happen that the process 1 is going to release the input output and then process 2 is going to be used, input output is going to be used by the process number 2. Then the another scenario is that, but at this time also process 1 wants the hard disk to access. Okay, in this case what is going to be happen that, okay, here the scenario is like this one. The process 1 is waiting for the input output, but process 2 is waiting for the input output, but process 1 is also waiting for the HDD that is accessed by the process number 1, and process number 1 is waiting for the hard disk to release and process number 2 is waiting for input output to release. So no, both the processes are in the waiting waiting state waiting state and wants other process to release the acquired acquired resources. So this condition, acquired resources, this condition is deadlock. Okay, so waiting, both the processes are in the waiting state and wants other process to release the acquired resources. This condition is nothing but the deadlock. Okay, I will repeat this situation again. Okay, here we have assumed that the process number 1 and process number 2 is running in your CPU and there is a set of resources such like a input output and your hard disk. Process 1 at this point of a time it acquires the input output system and process number 2 at this point of a time acquires the hard disk. Okay, but at some point of a time the process 2 requires the input output to get the execution of the process number 2, but the input output is acquired by the process number 1. Okay, in this condition one thing can happen, the process number 1 is going to release the input output and that is used by the process number 2 and it is going to complete the execution. But at the same point of a time process 1 also requires the access the hard disk. Means in this condition the process 1 and process 2 are both in the waiting state and wants other process to release the acquired resources. Means the process 1 wants to release the hard disk from process 2 and process 2 wants to release the input output from the process 1. So this situation, this condition is nothing but the deadlock situation. Clear, Siley? What is meant by the deadlock? Hello? Okay, Swapnali has said yes, sir. Okay. Okay, means you have cleared about what is meant by the deadlock. Priyanka?
यस सर समझ गया.
Okay. Okay, I will repeat it again. Those who are now not cleared this idea, because this thing is a very important one. What is meant by the deadlock? Okay, I will again explain the scenario. The process 1 is there, process 2 is there. Process 1 is accessing the input output. Process 2 is accessing the hard disk. Now, the process 1, process 2 requires the input output to complete its task, but it is actually in this point of time it is acquired by the process 1. Now process 1 also wants to access the hard disk, but it is acquired by the process number 2. Okay, so both the processes are in the waiting state and wants other process to release the acquired resource. Okay, this situation is nothing but the your deadlock situation. Okay, we can consider it as a deadlock. Okay, so again we will move to the your presentation. Okay, here it is. Okay, so the we have seen that what is mean by the process. Process is nothing but the program that is in the execution. Any kind of a task that is executed by the CPU is nothing but the we can consider it as a process. Any kind of a thing such like a printer spooler, name server, file server that is running on your system, we can consider it as a process. To execute the process we require the resources. These all the resources are the part of the program, just like components, just like your code, data, program counter, register is required to execute the process. So there is some distinction between the program and the process. Program, it is just a set of instruction, and when this program we are going to execute it into the main memory, it becomes a process. Okay, also we can said the process, it is a unit, means how much processes are executed in that CPU. So we can simply say it is as a unit for measuring the work done by the system. So these are the 5 major tasks that is that we have discussed about the what is actually mean by the process management. In the process management, the 5 major activities is completed, just like a creation, deletion, suspension, resumption of the process, mean again to start the process, process synchronization, process communication, and the deadlock handling. So we have seen in the detail what is meant by the deadlock. So this is about the activity number 1 that is run by the operating system as a operating system activities is nothing but the process management. Okay, then next one, the second activity is a main memory management. So there are the two types of the memories in your system. The first one is a primary or the main memory, and the second one is a secondary. So we can simply say the your primary memory is nothing but your RAM, ROM, PROM, EPROM present on your system is nothing but your primary memory or the main memory, and the second one is nothing but your hard disk, CD, DVD. So it is a permanent storage, and the first one is a temporary storage, means when you switch off your computer system, that all the data present into main memory is going to be erased. So it is also called as a volatile. So in the computer hardware and networking CHN subject, you may be seen this all the concept, uh, that is the types of the memories. So just as a revision, we have the two types of the memories in your system, that is nothing but the primary and the secondary. Okay, so here the CPU mainly deals with the main memory. Okay, why it is going to be mainly deal with the main memory? Because of the all the program and the processes that are going to be executed in which kind of a memory is nothing but the main memory. So the system is generally deals with the main memory. So all the instructions are executed in the main memory only. So those instructions that we want to execute it, we are going to move it into the main memory and then we are going to execute it. For example, we can take your C program that you have written into your turbo C. So these all the instruction we are going to move it into the main memory. We are going to load it, we are going to compile it, we are going to run it in the main memory, and we are getting the output there. So these are the tasks for the operating system to execute the all the processes to load into main memory and execute one. So which are activities are considered under the main memory is nothing but the to keep track of memory. So we know that we are having the 1 GB 2 GB of RAM. Nowadays your mobile also having the good size of a memory like a 3 GB 4 GB, any kind of a advanced mobiles having the 6 GB of RAM. Okay, and your system is also having the 4 GB of RAM, 8 GB of RAM, or the 16 GB of RAM. So we need to keep track of this all the memory where actually data is going to be stored and where it is going to be execute one. So this is the first task. Okay, this is the first task to keep the track of a memory. Then next is to decide which process to be loaded into main memory. So we know that there are the number of processes are running into your system. So there is a, when we are going executing the process, there is a different dependencies, like any process is waiting for that resource, then we will keep it into the queue, and the process which are in the ready state we are going to move it into your main memory and then we are going to execute it. So decide which memory we want to load it in main memory for the execution. That is the task for the main memory management. And allocation and deallocation of the memory space. So this is nothing but the another work, that is nothing but the allocation and deallocation of the memory space as per requirement. So these all the three activities we are going to carry it out as the main memory management. So we are going to repeat it again: to keep track of a memory, then to load these all the process into main memory, and allocation and deallocation of the space into main memory. Then we will move to the next point, that is nothing but the file management. So as the activities we have discussed about the process management and the mm, process management and the main memory management. So next point is about the file management, next activity. So the first point is about the file is the collection of related data. So we know that there is a, when we are going to create the text file, so it is nothing but some kind of a related data. We are going to bunch it together, so that is nothing but the file. The file could be a program collection of executable statement. So in the one file, just like a C program, C file, we are going to combine all the instruction that we are going to move it to the main memory and we are going to execute it. So it is a program collection of executable statements. Okay, the second statement. Then third statement, it could be a simple data file. Okay, here it is mistake, it is written as a date file, but it is a data file, stores the data defined by its owner. So who is going to create the file? The owner of that file is going to create that file and store it on the disk. So the system can store files on a disk. Okay, the system can store the files on a disk. Okay, who is going to allocate the space, who is going to access that space when we are going to delete that file? Then system is taking care about the storing of that all the files and deletion of that all the files. Then every media has its characteristics, speed, capacity, data transfer rate, and the access method. Okay, when we are thinking about the accessing the hard disk, so when there is any kind of a media, just like your hard disk, your pen drive, or any kind of a DVD, so for accessing that we have the different characteristic, just like a speed, capacity, data transfer rate, and access method. So you can simply go over the internet and you can search for the what is the speed, capacity for the USB. So we will get the different kind of versions for the USB, your pen drive, which are specifying the speed, capacity, data transfer rate. Okay, as a homework you can search for the these all the characteristics of the pen drive. So again the next point is about the OS decides where and how to store the data on disk. Okay, we are simply creating the files, we are simply creating the directories, and we are accessing that files and directories, but the user are really don't know about where the data is going to be stored. Okay, these all the things are taken care by the operating system. Okay, then different directory structure has going to followed. So when we are thinking about the Unix or Linux operating system, the tree structure directory structure is going to be followed in your Linux operating system. Windows also going to follow the directory structure, just like a C D E F that we are created. So this is nothing but the file management activities provided by the operating system. So which are the different kind of activities? So first one is nothing but the creation and deletion of the file, then creation and deletion of the directories. So in the Linux, to create the file, the touch command is going to be used. To remove the file, rm command is going to be used. Okay, how it is going to be used, we will see it into the practical session. To create the directories, we are going to use the mkdir. To delete the directories, we are going to use the RMDIR, means remove directory. So these kind of a commands that related with the file management activities provided by the operating system, and we are going to use it. Then manipulating files, accessing that file and modify that file is nothing but the manipulating that files and directories. Mapping of files into secondary storage. Okay, when we are going to create the new file, we are creating it into the main memory. So when we are pressing the control S, okay, it is going to be put into your secondary storage. So we need to map your file from the main memory to secondary storage. So that is nothing but the mapping of files into the secondary storage. Then backing up files into stable storage. Okay, this is the point, the same one as the last one, mapping of files into second storage. We need to move the file into the stable storage is nothing but the your backing of files into the stable storage. So these are the activities performed by the as a file management and by the operating system activity. Okay, we will move to the next point, that is nothing but the input output and input output system management. Okay, so the when we are thinking about the any kind of a thing or the task or the process are executed in the your operating system, then simply we require the many of the times we require the input output system to give the input. Okay, for example, when if we think about the writing, we have written the one program into your C language, then it requires to take the input. Okay, so we require to access the input output system. So in the Linux operating system, your hardware input output devices just like a keyboard, mouse, okay, these all are considered as a input output system. Okay, and we need to handle it. Then IO subsystem hides the complexity of hardware devices from the user. So user don't know about how to access the hardware. Okay, it simply gives the input and it simply wants the output on your monitor. Okay, so there is a complexity of accessing the hardware system, it is hidden by your operating system. So that is the activity here. Then buffer and spooling technique is going to be used to handle the input output system. So we have discussed the buffer and thus what is exactly means by the spooling, and in chapter number 1, and these technologies and these techniques are used here in the input output system management. So which are the key activities? The input output operation management, then hiding complexity of IO devices. Okay, so we have discussed just now keeping IO devices busy. Okay, so which number of IO devices we are having into system, that we need to keep it busy. So that is again a task for the operating system. And each of that IO devices requires the memory, and to assign that memory, to release that memory for IO devices, these four activities are performed under the input output system management. Okay, moving to the next slide, the secondary memory management. So just now we have discussed about the which kind of a data storage are into your system. That is nothing but the primary, secondary, and the cache. Okay, every place or the location in the storage device has its own address. Okay, how to locate the your we are thinking about the storing the data in your secondary storage or the primary storage. So how your 1 GB of RAM or the 1 TB of your hard disk, how it is going to be located? So every primary or the secondary storage or the cache storage having its own address. So by using the that address we are going to access it. Okay, yeah, where data is present or it may not present. Okay, it may be a free, but for every location there is a one own address having its by the secondary storage or the primary storage. So collection or set of all addresses that are available in the program is nothing but the address space. So for every devices has its own address space. Okay, where that data is going to be stored, that is accessed by address, and that is nothing but the address space. So you have to remember the concept like address space. And which are the key activities here? The managing the